In this video, we are building a real bullet hit system using the line tracing in Unreal Engine 5.7 with C++. You will see how to fire a trace from a weapon socket, how Unreal evaluates collisions in the world, and how a single line of code becomes the backbone of shooting mechanics, impact reactions, and damage logic in a third-person shooter. This is a practical system you can reuse in your own projects, and is part of the game we're building step by step on this channel, the Mad Gameverse. You can watch the entire series for free from the scratch, or jump into this tutorial, learn something new, and keep moving forward with your own projects. This is the Game Creator Accelerator channel. I am Tony Munoz. Support this channel by liking the video, subscribing, leaving a comment, sharing it, and ringing the bell so you don't miss the next chapters in this Unreal Engine shooter series. And if you want a clear path to grow as a game creator after office hours, visit william.com to learn more about the Game Creator Accelerator Lifetime Mentorship. It is a structured approach focused on creating real projects, sharing your work, and transforming into a provable, successful game developer. You can set a call with me to figure out how the GCA can help you. The link is in the description. Now let's get started. We're starting this episode with a character and montages for shooting while we are running. Previously, on the skeleton for this character, we created a barrel socket that helps us identify where the muzzle will spawn, and you can check the previous lessons to discover how we did this process. I will use this barrel socket to create the line tracing for the bullet hit. In other words, the line tracing will start in the barrel socket until a surface that they impact. I will go back to our shooter character where we control all this mechanic in C++. Inside the implementation file, we have the method that calls the shooting when we try to shoot with a character. Let's find the method. Here it is, the shoot button pressed. Let's close the section for the animation instance and open the ECollisionChannel mesh where we identify the barrel socket. I'm doing this implementation inside this if because what this if does is identify if we have a barrel socket, and if I have it, then I can create a line tracing for the bullet. So at the end, let's add a couple of lines. And we will use the command get world line trace single, and here we have the suggestion that I'm going to take. And now let's explain this one thing at a time. If you move the mouse over the line trace single by channel, you can see all the parameters that are required for this call. Let's go to the details of these different parameters. The first one is the parameter called HitResult. This is an output parameter. As you can see here in the out, it is telling you that this will give you information, data back. What information? Well, if the tray hits something, Unreal will store information in this hit result, like what we hit, where we hit it, and the surface normal. Then we pass the start location of the trace. Socket transform get location means that the trace starts exactly at the socket, which is usually the muzzle of the weapon. And we have the socket transform that we recover here that comes from the barrel socket. The next line is the end location. We take the same socket position, then add a forward direction of the socket multiplied by 5,000. It could be anything, but 5,000 is a good distance. In other words, we shoot the trace straight forward from the gun for 5,000 Unreal units. And finally, we specify the collision channel, which is ECC visibility. This tells Unreal to only consider objects that block the visibility channel, like walls, props, and any actors configured to be hit by visibility traces. So in one sentence, this line fires an invisible ray from the weapon's socket straight forward and checks what it hits first. When I started using this line of code, honestly, the thing that gave me more issues to understand was the collision channel, the ECC visibility. So let me get some details about this. The ECC visibility is the collision channel your line trace will use to test what it can hit. Think of it like this. Your line trace is asking the world, which objects should I care about when checking for a hit? The ECC visibility tells the line trace only interact with objects that respond to visibility traces. As you can see, the ECollisionChannel is an enum that has several values. If you want to check the options that you have for ECollisionChannel, keep the Control key down, move the mouse over the ECollisionChannel and click. Here will open a new tab and you can see all the options. We have World Static, World Dynamic, Pawn, Camera, Visibility, Physics Body, Vehicle, and Destructible. Depending on the object, you can define the collision channel that you required. Now let's close it and go back to our implementation. As you can see, we have the hit result and we need to specify it. So first off, let's declare our hit result. You can see that it is already suggested. So tap, and here we have it. Now we don't have errors on the out hit result. And we can use this parameter to get information about the hitting in case that this happens. Once we do this section, the next step is to check if we hit something. So we start with if hit result be blocking hit. Again, suggested. Let's tap to get the information. At this moment, it's suggesting to spawn a Niagara muzzle flash as well on the destination of the hit. This is something that we will check later on. But right now, what I want to create is a debug line until the surface that we are hitting. To draw that debug line, I need to include a library. And the library is include draw debug helpers. Let's go back to our function. And before the call to this Niagara spawn at location, I will add a draw debug line. And I will check this option. And what it creates is a line that will start with the socket location. Then we are passing the hit result location because hit result it is true. And we are presenting a red line. This false variable is a default I can use. And the number 2, if I remember right, is the thickness of the line. Perfect, 2.0. But I also want to draw a point to where the hit result is happening, to where we are impacting with our shoot. For that, we use a draw debug point. Here it is. And it's very similar to the draw debug line, with the difference that we don't have to pass the starting point. In this case, it's just the destination. Then it's the size of the point, the color, and a priority that I will check the default, which is 2.0. Before we continue, let me share something with you. This channel is part of a bigger journey called the Game Creator Accelerator Lifetime Mentorship. And it is built especially for people who already have a life in motion, a day job, responsibilities, a stable routine, but still feel that need to build something meaningful in game development after office hours. The goal is a measurable transformation into a game creator, not just watching tutorials, not just collecting notes or certifications, but building proof through learning skills, creating projects, using proven methodologies and strategies, and setting a brand for yourself and your creations. You and I work together to build your 3D Unreal Engine games, learn core principles and how to solve challenges, and grow your social media presence to share your work with studios, publishers, recruiters, and players. This is the same approach successful indie creators use, myself included. But unlike me, you don't have to learn it the hard way. Today, learning in isolation, submitting applications, or developing without leaving a mark doesn't work. You grow by creating, sharing, and making opportunities come to you, not chasing them backwards. In this program, you will learn how to stay consistent and committed to you with the support of myself and our community. The GCA mentorship is helping transitioning to the work of their dreams without jeopardizing their current circumstances. If you want to learn more, visit Woolon.com and schedule a one-on-one chat with me. The link is in the description. Now let's save and go back to Unreal. Compile. Now I require to place an object that I can shoot. So let me see where the character starts. And now let's add an element, any actor, in front of it. Something like this cube. Let me scale it a bit. If you select the object and you look for collision in details, you will see this parameter that is called the collision presets. Remember that in our setting, we said we want to identify this hit result with ECC visibility for the collision channel. If you use this default, it will work, but also you can define a custom collision. And then you can say what are the elements that you want to block, ignore, or overlap. Right now, we're blocking visibility for this object, but every object can define their particular channel. Now, let me put it back to the default. Now, let's test it. Okay, let me move away and try to hit the floor. There you go, and you can see the green point of where the hit is happening. And if I do the wall, place myself close to the wall, there you have it as well. Why? Because both surfaces are capable of giving results for the hit result. Understanding the collision presets is key because sometimes you are trying to shoot in an object and you don't identify that the shooting is happening because there is no collision, and the reason is the setting of the collision presets. So keep always in mind this detail. If you are debugging your code and the collision is not happening, check the collision presets. We built a line trace in Unreal Engine 5.7 using C++, fired from a weapon socket, evaluate collisions in the world, and saw how this single system becomes the foundation for shooting mechanics, impact reactions, and damage logic in a third-person shooter. This is one of those core systems that turns prototypes into real games, and it's a key building block of the shooter we're creating step by step. Support the channel by liking the video, subscribing, leaving a comment, sharing it, and ringing the bell so you don't miss the next episodes of the creation of Mad Gameverse, our third-person shooter. The full code is available right here on the channel for you to study, copy, and use it in your own project. This series and many others on this channel are all about building real skills for the gaming industry and pairing them with the right methodology to create a long-term success. And if you want to go further with a structured path, visit woolon.com to learn more about the Game Creator Accelerator Lifetime Mentorship. You can also set a time to chat with me directly and see how the GCA can support your journey toward job opportunities and long-term independence in the gaming industry. The link is in the description. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.